everyone. Today we will be discussing about logarithmic function. When I talk about the logarithmic function, let's say f of x is equal to log x to the base a. Now there are two variables, or I can say that there are 2 points which you need to consider. One, what is the x? What is y? So x is the argument. X is a argument and a will be the base of the log, right? So when I say that x is argument and a is the base of the log, that means there must be some values that are satisfied for these x as well as a, or I can say there are certain values or certain values called as in the domain which could be put in these in the place of x and a, so to get the output f of x. So let's say consider this as some function f of x, which is nothing but log a x. We are putting the values input, which is domain, and taking out the values, which is range, right? So the function f of x is in itself, the function f of x is in itself a very simple function, whereas where it is giving that x must be greater than 0 and the value of a will be greater than 0 and a should not be equal to 1. If you have studied, or if you have studied the exponential function, if you have not watched, I have included one video over exponential function. If you want to, you can. If you want to watch it, you can go ahead and watch that video, right? So if you know about exponential function, you know very well that an exponential function could be expressed as b to the power a to the power x, right? When I say b is the answer for a to the power x, now this x is something that we need to calculate, right? Or I can say to more simplify it, I can say that when I write f of x equal to log a x, then as the a goes from right hand side to the left hand side, it goes in as in power a to the power f of x is equal to x, right? So we are just powers calculating the powers, right? Earlier in the exponential case, we will in the exponential in the exponential case exponential case we were calculating the answer b a to the power x, as we were knowing that what is x, and by knowing what is x we were calculating a to the power x, which is resulting in b. Now in the logarithmic case, the case is different and the case is inverse, right? Now in this case we are saying log b to the base a is equal to x, right? If you solve it further, you will get a to the power x. This a will go here, right? And x goes in the power, so it will become a to the power x is equal to b. So logarithmic and exponential functions both are inverse of each other, right? Both functions are inverse of each other. They are not reflections of each other, they are just inverse of each other. There is a very big difference between the reflections of the functions and the inverse of the functions. I think you might have got a glimpse of it. Let's take some examples. For example, I'm taking log 3 to the base 9. When I talk about this, I can say that it could be simplified as log 3 to the 3 square, or 2 log 3. This will become 1, and hence the answer is comes out to be 3, right? That means log 3 to the base 9 comes out to be 2. And if you even simplify it by carrying out the values, by making 3 go to the right hand side and 2 on the power, then it will become 3 square is equal to 9, right? So this is a very normal example of log. You might be knowing till now that what it actually means, right? So let's get ahead with the graph of the log, the main part or the main portion of this video, the graph of the log logarithm. So I have a function f of x represented by log to the base a x. Now there are two conditions which are possible. Either a is having the value greater than 1, or a is having the value between 1 and 0. For both the cases, the graphs are different, right? So let's take the case 1. In the case 1, I am saying that the value of a is greater than 1. As the value of a is greater than 1, so we will plot the points to get the graph. Let's say x and f of x, right? And I'm taking the base as 2, or the value of a as 2. So the graph will be f of x, graph will be of f of x equal to log 2x, log x to the base 2. That's how we read it. Yes, you might be knowing it. If I put x is equal to 0, will there be any value of f of x? It will not be the value. There will be no value of f of x, as earlier we have specified that the value of x must be greater than 0. If x, the value of x must be greater than 0, so 0 can never be the value of x. What will be the value of x then? Let's start with taking 1. If x is equal to 1, then we know that log of 1 is equal to 0. If x is equal to 2, then log of 2 to the base 2 will be 1. If x is equal to 4, then the answer will be 2. Let's take some negative values. If x is equal to minus 2, can we take x is equal to minus 2? Again, that condition arises. This condition states clearly that the value of x must be greater than 0. So we cannot take the value x is equal to minus 2. So again, 8, 3, 16, 4. Okay, these points are enough to draw the graph. So let's say we are drawing the two axes. This is x, this is f of x, right? Now it is the point 0. For x, we are plotting 1, 2, 4, and somewhere here 8. Then f of x is 0 for x is equal to 1. For x is equal to 1, the y is 0. That means somewhere here, or not somewhere here, it's obviously here, right? For x is equal to 2, the value of y will be at 1. So let's say this is 1, this is 2. So here for x is equal to 2, x is equal to 4, apology, x is equal to 4, the value of f of x will be at 2. So I can say that f of x will be here. Now some of you might be wondering that why the graph is shifted to the negative y-axis, as we can take further more points like 1 by 2, 1 by 4, and if we solve these points, then we can say log of 2, 1 by 2 will be log of 2, 2 to the power minus 1 or minus 1, right? And if I take of log 1 by 4 to the base 2, it will be log 4 to the base 2, or I can say minus 2. So the value is shifting, the value is shifting towards the negative y-axis. This is the graph that we can plot it, that we can plot, right? And it is not like I've drawn the line just to extend it. The graph comes here, the graph comes here for the values which are less than 1, for values which are less than 1 but greater than 0, right? So what can I say from this? That the graph of f of x is equal to log x to the base a, where a is greater than 1. We have taken that case where a is greater than 1, is a curve, is a curve, and the graph and the graph is increasing, or it is an increasing, behaving as an increasing function, right? This is what we can infer. Now again a question arises, how can we say that the graph is an increasing or it is behaving as an increasing function? So either you observe it directly, or we can even prove it. Let's say we observe graph from left to right. So as we move from left to right side, we are seeing that the values of x is increasing, and corresponding to that the values of y are also increasing, as initially the values of y are in the negatives, but as the graph is increasing or the graph is moving forward from left to right, the values of y are in the positive side, and then it is increasing it is increasing, right? So I can say that the graph is increasing. Also we can prove it, right? Okay, we can prove that the graph is increasing by considering some points. Let's say I'm taking the points, let's say I'm taking the points x2, and for x2 there is a point on y-axis which is f of x2, then x1 on x-axis, and for x1 there is a corresponding point f of x1, right? Now just uh, see the movement of the input and the movement of output. If the movement is same, what I mean to say, if the input is increasing, then the output must increase. If the output is also increasing, then it is an increasing function. But if the input is increasing but the output is not increasing, it is decreasing, then the function is decreasing. It is as simple as that. So we know that x1 is less than x2, right? And f of x1, from the graph we can say f of x2 is greater than f of x1. So as we moved from x1 to x2, the graph moved from f of x1 to f of x2. That means x2 increased, till x2 it increased, and the value of y also increased to f of x2. Hence the function is increasing function, as the input is increasing and corresponding to that the output is also increasing. So we can say that as as the input of the function input of the function is increasing. Corresponding to that corresponding to that, the value of f of x, or the value of the value of output is also the value of output is also increasing, right? Which shows that it is showing an increasing behavior when the value of a is greater than 1. Now taking the second case, I think you might have got that case 2, when the value of a is less than 1 but greater than 0. In that case, I can say that the value could be any function, or value could be anything like 1 by 2, 1 by 3, 1 by 4, and so on, right? So in that case, or in that condition, what I can infer is that log, if f of x is equal to a log x to the base a, then as x is as a is something which is less than 1, as a is something which is less than 1, so referred as it could be referred as log, let's say we are taking the example log 1 by 2, 1 log x to the base 1 by 2, then in that case it could be further simplified to log minus of minus of log 2 minus of log x to the base 2. This is the function that we were going to take to plot the points, right? So what function we are having, f of x is equal to minus of log x to the base 2, and the points will be x, f of x will be, let's say x is equal to 1, then the log will be 0, or the function will be 0. If x is equal to 2, then the answer will be minus 1. If x is equal to 4, then the answer will be minus 2. If I take x is equal to 2, then the answer will be 1. I am just prerequisiting this fact that you might be knowing the logarithmic properties. That's why I'm calculating directly. If 1 by 4, then it is 2. These points are sufficient to draw the graph of y is equal of f of x is equal to minus of log x to the base 2, where the base is less than 1. To We have just converted the base, keeping or putting a minus sign in front of the log. Otherwise, the whole situation is similar to log x to the base 1 by 2. Now in this case, let's plot the points. So what can I say is that the graph is similar to this, right? If you see the previous graph, this was the previous graph, and if you see this graph, these both graphs are quite different to each other. Of course, they will be different because the conditions have changed, right? We were talking earlier in the case that when a is greater than 1, and in this case when a is the value between 0 and 1, right? So now what can we say from this? Firstly, that the graph of f of x is equal to log x to the base a is a curve, and it is decreasing graph, or it is decreasing graph when a is less than 1, greater than 0. Now, how it is a decreasing graph? So it is the decreasing graph in such a way. Again, we can take some points. Let's say I'm taking this point, and corresponding to that, I'm having this point. So let's say I'm taking a value x1, and for x1, I'm having a value f of x1 at y-axis, and another I'm taking a point x2, and for x2, I'm having a corresponding value which is f of x2. Now, we only have to observe that the input, if increased, then what is the result in the output? If the input is increased, then the output, if and the output is increased, then the function is increasing function. If the input is decreased and the output is increased, that means the case is different or opposite. In that case, the function is decreasing function. It is quite simple, right? And we can easily observe it with the graph. If you observe directly, and it is automatically showing that the graph is decreasing as we are moving from left to right. The graph is continuously decreasing because at left, starting from the left, the values of y are very high, but as soon as we move from to right side, the values of y becomes negative, right? So it continuously decreases. So either you see in that way, or you can even prove it in such a way that x1 is greater than, or sorry, x1 is smaller than x2, and for f of x1 and f of x2, we can say f of x2 is smaller than f of x1, or f of x1 is greater than f of x2. If you observe these two conditions, then you can clearly see that for x1, for x1 greater than of x1 less than x2, the answer becomes f of x1 greater than f of x2. Hence, at one side the input is increasing, but with the increase in output, with the increase in input, with the increase in input, the value of output is decreasing. And as the input is increasing but the value of output is decreasing, we can say that the function is the decreasing function. So I can say that value of input, the value of input is is increasing, but the value of output is decreasing. Hence, the function is the function is decreasing. Function and the function is decreasing function when a is less than 1 0, right? So I think we can conclude here that we can conclude here that for the function f of x is equal to log x to the base a has two possible scenarios. Firstly, when a is greater than 1, when a is less than 1 and greater than 0, right? And x must always be greater than 0. X must always be greater than 0. There might not be any condition where x is not greater than 0. X must always be greater than 0, right? That is a domain of x. Okay. So for these two conditions, if a is greater than 1, then the function is showing increasing behavior or increasing function, and if a value of a is less than 1 but greater than 0, then the function is showing decreasing behavior, decreasing behavior, right? So this is how we will conclude with this topic, right? I think you might have understood this. Okay, this is me, Prakhar Jain. If you like this video, give a thumbs up. Bye.